Alright, remember on slide 1, you're mainly giving an opinion of, like, why you feel the way you feel. So if you were still on slide 1, wrap it up and move on quickly, please. Everyone get one of our worksheets. I have a bad habit of missing people sometimes. You said thank you when I dropped it at your table, too. Only if it's above what you've already done. So if you go back to the very beginning of 8th grade, probably not.
So anything on integrated math 1?
Is that part of our class? Like, I can add classes to you guys if you really want. Because it needs to be, so like computer programming is not part of our class, quote unquote. So like that would not give you points. Does that make sense? So like I could add integrated math 1 because I mean that makes sense. So right now we have 8th grade, 7th grade, high school geometry. I can add integrated 1. There you go. I just did. So now if you do work in integrated 1, that will also... Actually, I should add algebra 1 too. I mean, if you guys are wanting to do extra work, who am I to stop you? Hey guys, please check the instant feedback that Desmos is giving you. When you get to slide 6 and it says you need a worksheet, that's the back of the page I gave you. Yep. So we're talking about volume today. Can anyone help me with what we could write down for a definition for volume? Alex?
Amount of space that specific objects takes up.
Yeah, like the amount of stuff in a thing, right? Yeah, the amount of interior space inside of something. So, guys, this definition for you is really whatever you want to write. But it's the amount of space inside of something, right? Volume is space inside of something that we normally go to, like, cubic inches because we think about literally inches being cubed. Kind of hard to draw, especially with a heavy pen. Or we could have feet cubed or meters cubed, or we could even have miles cubed. We've talked a little bit in like crazy big amounts, like how many miles cubed are the Great Lakes, or like how many miles cubed of waters in the ocean. That's when we would use really big measurements like miles cubed. We were talking about like an insane amount of volume. And that's why M is always meter, MI is always miles. Right? Obviously MI would not be meters, but if you're doing miles, you cannot abbreviate it as M. M is for meters. What are some, like, labels that we wouldn't use for volume? Ahmad?
Meters squared.
Yeah, like meters squared, or even just like meters. Now, funny enough, more examples that you might not, I wish I hadn't drawn this. CC. You ever watch any medical shows?
I do. 57 cc.
He needs 50 cc's stat, right? Well, stat means right now, but what does cc mean? Anyone have a guess?
Closed captions.
No. Cubic centimeters. Guys, a cc when you're watching a medical show or when you're at the doctor literally just means cubic centimeters because the rest of the world, okay, aside from a couple countries, the rest of the world uses the metric system. So would they say, oh, he needs 5 ounces? No, that's a stupid Americanized. They would use cubic centimeters. Or, like, you know, the other measurements that we all agree on except for America. Yeah, I don't really know facts characteristics that we need. So I'm just going to unpause you guys to be able to keep going. All right, there you go. Yeah, Alex.
Is the part 6 of the Prisms just the back of the page?
Yes, sir. That's what the note at the top of the page tells you. So we're not going to talk about spheres today, although like some of you are using spheres, which is totally fine. But we're not actually addressing spheres today. We'll do that tomorrow. So if you're going to ask me to explain something about spheres, I'm not going to. I will tomorrow.
No.
All right, I want to see if anyone can help me yet. Also, because I don't see many pencils moving. Beatrix, have you figured out if the height of a cone is 2 times as large as the height of another cone? And I guess we're going to assume that the like circle part of the cone is the same, right? The base part, because they don't say anything about that. So, did you figure out how those 2 cones are related? No, not yet. All right, Laurel, did you figure it out?
Like two like volumes of the smaller cone, the one large cone.
Claire, well, that didn't work very well because you're sitting next to each other. Maddie, I'm guessing if Beatrix hadn't gotten there, you hadn't gotten there probably.
We haven't talked to each other.
Vivian, do you agree with Laurel? Wait, did you do this one?
Well, see, the thing is,
No, there's no the thing is. It's yes or no. Did you do this one yet?
no, but I can do it.
If I have a cone and I double the height and that's all that I change,
Well,
does the volume become double what it was?
No, it doesn't because then like if it's getting smaller, right? It's getting smaller.
Hey,
you won't have
don't-
much as
Don't just guess. Let's try it, right? Try it in your activity. If you haven't yet, try it. Two cones, same cone, one height, double the other height. Compare. Huh. Exactly 2 times as much volume. I think I can trust that now. The big is exactly... So when I make the height twice as large, my big cone, like what my dog has to wear when she has surgery, is 2 times the little cone, or the small cone. All right, diameter of a cylinder is 3 times. Test that out. Please do not just guess and write an answer here. Test that out, that the cylinder, one cylinder is 3 times the diameter of the other cylinder. Guys, and this is where I love Desmos, of like, I can just click and it makes the shape for me, right? And I can just like drag, so I want same height. I want triple, uh-oh. If I can't drag up to 6, maybe I need to drag this one down. I'm not going to click compare yet. I need you guys to. Do you think it will just be triple? Because we tripled the diameter. We kept the heights the same. I wish there was a pause. There was triple. 9? 9? Holy cow! So if one cylinder, the diameter... Okay, so if D is times 3, volume was times 9... Anyone have a hunch of what happened? What if I did one diameter that was 4 times the other diameter? Let's try that. What if I do a diameter that's 4 times? Try it. You have it in front of you. Try it. I did not pause you, right? Yeah, you're not paused. Gus?
I think I just figured something out.
What'd you figure out?
Like getting squared.
It's getting squared because what we did with the times 4 gave me 16 times the volume. Huh. Interesting. All right, keep going on your own. I'm going to give you a few more minutes on your own. This has been stuck in my head. And actually, let's all hop over into the other activity, the cones activity. So if you had gotten this done and if you had went to do some con, leave that tab open, but come back to Desmos and let's jump into the cones activity. Oh, I never assigned it. That's because I wanted to make sure you guys didn't click on the wrong thing. Hey, refresh your page. It should be there now.
Wait, I'm confused. It was there the first time.
Was it?
Yeah.
Cylinders was there. Or wait, no, yeah, that's what I meant. Cylinders next. I'm going to go in and pause cones. Go into cylinders, because we want to formalize what we just learned about cylinders. Yes, Alex, can I help you?
We don't have to finish the first system.
Correct. That's why I said leave and go over into. When I give direct instructions, you can trust them. My bad. I got too excited about cones. Because, you know, I'm thinking about ice cream. Yeah, Gus, I don't know why somebody plugged straight into the power strip when you could just grab the gray extension cord and plug into that. Okay, well then just use that charger. That's fine. Just use the charger that exists there.
guess yours probably
You should be in cylinders now, Alex. I spoke wrong. I said cones because I got excited about cones. You should be in the cylinder activity. Amir, move on from slide 1, dude. You're taking too long with that. Ooh. Vivian, you have slide 5 correct. I'm going to leave it hanging what that means about everybody else. Cough, cough. Means you're wrong. Vivian has slide 5 correct. In geometry, is there really an up or a down? Doesn't have to be, right? Shapes can be turned and rotated and flipped, and
I had this at the previous session.
and it's wrong. Think deeper, Alex. You need to be a bit more confident and not running straight to me when you have a moment of like unsurety. So many thoughts. Like, what game am I going to play tonight? By the way, Target is doing buy one, get one, or buy two, get one free on all books and board games. So if you are looking to pick up some books or board games, my wife took advantage of that last night 3 times. She bought 9 books last night because she has a problem.
Force me back.
So come back to slide 5. And let's look at the next worksheet that we have. And you don't necessarily have to write this. I don't know why I've already gotten out 4 sentences and yet people are talking over me. Understand how all prisms. Now we're going to have to do a little bit of memory of what does it mean for something to be a prism. Because obviously we know what a cylinder is. Obviously we know what a cone is. But can anyone remind us of what a prism is? I guess I should probably pause my music so I'm not fighting with that too. Alex?
Any shape that has 2 parallel sides.
I think that I want to make sure that there's no holes in that definition because that was a very concise definition. I think we need a bit more detail. What you said is true, but I think we need a tiny bit more detail to make sure that it covers all the bases of what it means to be a prism? Vivian?
Like, parallel bases.
So parallel bases, you are correct. We still need slightly more detail.
They can be
Yeah. So these are all examples of prisms. And what might have frustrated you when looking at this slide and me telling you that you're wrong is B a prism. No, come on, that's silly. Is C a prism?
Yes.
Yes. D? No, it's not, and it can't be. It could be a pyramid if we give it the top of it.
Wait,
but
didn't you I was thinking you cut off the corners and then
Well, no,
plug them on the top.
yeah, okay, so if we start cutting things apart. E, is it a prism?
Yes.
Yeah.
F?
Yes.
No.
Yes. Yes. Because the definition of a prism is to have congruent bases, and the other faces are all rectangles to connect the congruent bases, but it doesn't matter what shape your base is. The base could be a star, as long as your connecting sides are rectangles. Now, this is where some people are like, wait, what about a cylinder? Your base could be a heart as long as you connect up to another heart. But then again, your brain might be saying, but wait, would that heart-based cylinder be connected by a rectangle? Yes. Because if you have a cylinder and you pull it out and you ignore the fact that we know the top and bottom are circles, what's the other surface area that it has? A rectangle. When you unfold it, it is a rectangle. So, a cylinder, not cylinder, a prism is congruent bases, right, that will be parallel. So congruent parallel bases connected by rectangles, where you have like the S in parentheses of like it might be plural. Because with like if you did a heart base or if you did a circle base, there's only one rectangle. Now you could, if you look this way, you could say, oh, there's multiple. But no, the rectangle is really just the circumference by the height. So your formula there, where I went ahead and wrote in big B, because it does matter that when we say this, we say big B. Because if you just say B, what else could just B be talking about? It could be the little b that we use for like base times height for triangles, right? So we do need that to be big B. Up here, we're going to fill in why it's big B. What is big B actually representing here? What does big B stand for? Base what? Base what? Shout it out. Base area. So for all prisms, any object that is a prism, it's the base area times the height. So big B, right? The pentagon, big B. Now here's the tricky part though. With a rectangular prism, if I flip it this way, do I have parallel congruent bases connected by rectangles? Yes. Well, if I shove that up. If I flip it this way, do I have parallel congruent bases connected by rectangles?
Yes.
If I flip it this way, do I have parallel?
Yes, sir.
Yeah. So a rectangular prism, you can turn whatever way you want, and it is a prism. But a cylinder, it's still a prism. Right? But now my base, guys, does base mean bottom? No. It does not have to. Base means the base of the shape. Base is like where you start, right? Start at the base. You start climbing a mountain from the base. Right? So base does not mean bottom. Base means the shape that we can see on both ends, which here could be any of our faces, but over here would have to be the bottom pentagon, or it could be the top pentagon here. Here it has to be the circle. So it's always base area times height. So let's practice that real quick down here. Work with your partner to figure out what's the volume of this. Now wait, why did I say same formula in like quotations? Because, guys, will the formula for this big B be the same as this big B? No. Because this is a pentagon. And this is a circle. So, where this is the same formula, quote unquote, and you could write it out here again, especially because I kind of squeezed it in there. It's the base area. So I need to find that first, which will not be the same for every prism. But it's the base area times the height. So work with a partner to figure out what is the volume of that cylinder right there.
It's too high.
Simon, how do we find area of a circle? Pi times radius squared. So please make sure we're working with radius. What's the radius here? Ahmad, what's the height here?
5.
Why is the height 5 when that's like how long it's laying on the ground?
Because that's the only other measure other than the base that we can use. That's basically just provided.
Guys, your height is really distance between bases. So if you need to make a note that height is actually just the distance between bases, it's not always how tall it is, unless we stand it the right way, right? But the height is distance between bases. Really, Emery? Emery, shut my door! Or, oh, never mind, that was you. Thank you. Leaving my door open in the middle of class. So wait, again, do I have to turn pi into 3.14? Not necessarily. What's 3 squared? What's 9 times 5? So I could write my volume is 45. I got too excited about writing pi. Pi, what'd my label be? Centimeters cubed. Or if we do the math, did anyone do 45 times pi? Yeah, what'd you get, Simon?
I got 141.4. I got 1.4.
Yeah, hey guys, this is why we don't like to start converting pi. Are we using 3.14? Are we using the actual pi button? So that's when we turn this into approximately equal. So you said 141.4. Yeah, guys, you're going to get a slightly different answer depending on what you use. Centimeters. Yeah, so you used a more precise pi. And as long as that makes sense, you guys have what you need for today. Tomorrow we will do cones, and then we will do spheres. You probably already have figured out how the cone relates to the cylinder based off the first activity, but we'll formalize that tomorrow. Have a great day. Thank you. Oh, wait, yeah, Con. I had it ready. It was all set. All right, so they were at 75%. All right, do you guys think we'll close this ring?
Yeah.
All right, I sure hope so, right?
Actually, no.
At least super close.
All right, ring 4. Let's see where we get. Do you think we'll close ring 5?
No. 50%.
How much work did we do? How much work did we do? Any more? All right, there you go. Have a great day.